How are you? How are you? Can you hear me? How are you? Are you there? Can you copy me? Can anyone hear me, please? Okay. Can you hear me, please? Okay. Thank you. Thank you. So now let's get started. Now, please take your natural science notes. Go to the exercise part. We're going to correct some exercises we did the other week. And let's go to the exercise number 15. And you have there an exercise about the correct choice. 15.1. So, which of the following is not a source of natural light? And we can choose between lightning, a jellyfish, fire, and flashlight. Not a natural light. What do you think? What do you think? What do you think? We are here in the exercise number 15.1. What do you think is the correct answer? A, B, C, or D? What do you think? Is lightning? Lightning is the English for our Spanish relámpago. A jellyfish, you know that. Fire, flashlight. What do you think? Yes. Thank you, Rodri. Thank you. It's flashlight. This is not a natural source of light. Flashlight. Now go to the next exercise. So, how does light travel? And this is a little bit difficult. Oh, this part. So, A, it travels in wavelengths. It travels in a straight line. C, it travels only during the day, and it travels farthest at night. What do you think is the correct answer? A, B, C, or D? What do you think? Ines, very good. Very good, Celia. Very good. It travels in a straight line. So the correct answer is B. Okay. Although you know that inside, light is composed of many different waves, and each one of them have a wavelength. Very good. Go to the next exercise. The next question. What is our main source of light energy? It's very easy. Stars, fire, sun, solar panels. What do you think? 15.3. What do you think? Julia, what do you think? Miguel? Yes, Ines, very good. The sun is our main source of light energy. So stars have light energy, fires as well, and solar panels as well. But our main source of light energy is sun. Okay, let's go to the next exercise. So the speed of light, A, is always the same, changes when traveling through different objects. C, doesn't exist in the darkness, is not as high as that of the sound. What do you think? I have some problems with with the image, but this is not important. What do you think? What do you think? We are in 15.4, talking about the speed of light. Yes or not? You think B? Yes. It changes, it changes when traveling through different objects. Good. And oh my god, I want to finish that. Which of these statements is true? And we had to choose between optics is the study of light. UV lights are often used by forensic scientists to see details that are not seen by the naked eye. Light moves at the fastest known speed in the universe, or all of the above are true. So, what do you think? 15.5. What do you think? Which of these statements is true? Which of them? What do you think? Is optics the study of light? Yes, it is. UV lights are often used by forensic scientists to see details that are not seen by the naked eye. That's true as well. Is it true that light moves at the fastest known speed in the universe? Yes. So, D is the correct answer. All of the above is true. This is the correct answer. Okay? This is the correct answer. Very good, very good. So now you have here a very little test about light. So it's not how it is, it's how you see it. So many of the things we think are true of the world turn out to be true only of ourselves. We think tomatoes are red, but in fact we only see them that way. If our eyes were built differently, we might see the light photons that tomatoes produce as light of a totally different color. And there is no real way any of us can be sure that what we see as red is the same as what anyone else see as red. There is no way to prove that my red is the same as yours. So then, are tomatoes red or not? What do you think? Yes or no? What do you think? Are tomatoes red or not? What do you think? They look like red, but what do you think? Are they red or not? Waiting for your answer. Are they red or not? No, they are not. They are not. So this is the way we see it. And why is it? We're going to see it with a clip. So pay attention about the reflection of light. This is an interesting video clip. Pay attention to it.
How do we see things around us? You would probably say it's the eyes that help us to see the objects around us. But will our eyes be able to see these objects in dark? No, we need light to see things. Without light, we cannot see the objects. But where is this light coming from? This light is coming from this source, which is a fluorescent bulb. You see that...
So this is a fluorescent bulb. This is a kind of a light bulb. Okay, so this is not a natural source of light, but thanks to it, we can see the rest of the objects in this room.
This bulb is emitting its own light. The objects which emit their own light are called luminous objects. Can you give me any other examples? Incandescent light bulb, the sun, the stars are also luminous objects.
They are luminous objects because they can produce their own light.
What about objects such as this table and chair? Do they emit their own light? No, these objects do not emit their own light. Such objects are called non-luminous. Almost everything around us is non-luminous. Objects made up of wood, plastic, cotton, metal are all non-luminous. What about the moon and the planets? They are also non-luminous.
Okay, because they don't have their own light. What the stars
But if the
do.
moon is non-luminous, then how come we're able to see it at night? The answer to this is reflection of light. The reason we're able to see any non-luminous objects around us is because of the reflection of light. Reflection of light can simply be referred to as change in direction of light or bouncing of light from some surface. Just like the ball bounces from the ground, light reflects off from a smooth surface.
This is reflection. Okay, this is the direction, and when light hits an object, it got deflected. Okay, and this phenomenon is called reflection of light, and this is influential to explain how can we see objects. Why we see that tomatoes are not red. Okay, red is the color that is reflected by the tomato, and this is pink because this is the color that is reflected by this dress.
Let me try to explain this in a simple way. The light from the source strikes the object and bounces off from its surface. And when this light reaches our eyes, we see that object. And this is how we see non-luminous objects. When the object is kept in front of the mirror, its image is formed in it. But will we be able to see the image in the dark? No, we won't. So the formation of the image is also due to reflection of light. Let this object be our human body, so at the same time we are looking at the image.
Pay attention. Okay, this boy is looking himself into the mirror, and he is able to do that, to see himself, because of light. Light comes from this way, reflected to the mirror, is reflected to the eye of the boy.
First tell me, is our body a luminous or a non-luminous object? Well, it's non-luminous. Human body cannot emit its own light. So the light from the source is first incident on the human body.
Can you see it?
It gets reflected from it, and this reflected light strikes the mirror. This light is further reflected from the surface of the mirror and reaches our eyes.
So this is reflection, the change of direction when light hits an object. Okay, and when light hits this shirt, this light is deflected to the mirror. But first, this object, this fabric, absorbs all colors but red.
This is how we are able to see our image. Now, obviously, this is not the exact picture of the happenings. I just wanted to give you the intuitive feeling into how this happens.
Very good. Now, please, let's go to our text again. Please, back to our text, and you need your text part. So, and light and objects. So you know about luminous objects, they emit their own light. So this is a candle. And another example could be the sun, could be stars, could be fire, could be light bulb. And non-luminous objects are objects that don't emit light, but they can reflect light from other sources. And according to that, we have three different kinds of objects: transparent objects, opaque objects, and translucent objects. And the difference is that transparent objects are these objects that can less pass directly light through them. So this is a lens. Okay, another example are air and water. They are transparent objects. And we also have opaque objects. They can't let light pass through them, but they can reflect light. So light won't pass through them. An example is an animal or a book. Okay, but they don't let light pass through them, but they reflect light. That's why we can see them. That's why we can't see transparent objects. And finally, we have in the middle we have translucent objects, and these objects let light pass through them, but the objects on the other side are not clearly visible. And examples are tinted plastic or butter paper. And we had another exercise there about this object in your exercise section. So exercise 17, and you had to classify these objects are transparent, opaque, or translucent. What do you think about glasses? Are glasses transparent? Are they opaque or translucent? What do you think? Talking about glasses, what do you think? What do you think? Are glasses transparent? Are they opaque or translucent? What do you think? Okay, transparent. Good, very good, very good. They are transparent. Now let's move to this stained glass window here. This stained glass window. This is the English for our Spanish, vidriera. You can see them in many places, especially churches. Okay, stained glass window. What do you think? Are they transparent? Are they opaque or translucent? What do you think? A stained glass window. Is it transparent? Doesn't like it. Opaque? Not very sure. Translucent? What do you think? What do you think? Talking about the stained glass window. Very good, Ines. Very good. This is a translucent. So, this window can let light pass through it. Okay, but we can't see clearly behind it. Very good. Now, go to this net curtain. This net curtain. This is a curtain you can have in your drawer. Okay, in your bathroom. Okay, what do you think about this net curtain? Is it transparent? Is it translucent? Is it opaque? Julia, butter paper is what in Spanish we call papel de... Butter is margarina, is mantequilla, papel de mantequilla. So, what do you think? A net curtain, we're talking about that. This part, the net curtain is... What do you think? Pablo de Soto, I'm waiting for you. Net curtain. Translucent, very good, Celia, very good, very good, very good. What about this brick wall? Let's move to this brick wall. What kind of object is this brick wall? Is it opaque? Is it transparent? Is it translucent? What do you think? Talking about the brick wall. What do you think? I'm waiting for you. What do you think? Julia, butter paper is the paper we have wrapping our butter. Es el papel que envuelve la mantequilla. Okay? Opaque. Very good. And then finally, we have the exercise number 18. So you have to write a sentence to explain what each word means. And transparent is an object that let light pass or not. What do you think? A transparent object. Can it let light pass through it or not? Yes or not? transparent object is an object that let light pass through it. Okay, so this is different from an opaque object, and translucent is in the middle. Very good, very good. Now please go again to your text part, and this is really interesting. So how does light behave? Can you see this duck? Okay, this duck looks like it is broken, but it is not. Okay, this is a characteristic, a feature of light. So light waves travel in straight lines through empty space, in the universe. So when light waves move from one material to another, they behave in interesting and useful ways that we describe as reflection and refraction. And this is reflection. Reflection is when light hits the surface of an object, then that light travels to our eyes so we can see. So this is the source of light. It hits the flower, okay, and as the flower is an opaque object, an opaque substance, an opaque body, when light hits this flower, light gets reflected and we can see it. So this is reflection. This is reflection. And there are two types of reflections. It all depends on the surface. When the surface is totally smooth, this is specular reflection. You can see through it. Okay, this is the mirror. Okay, and diffuse reflection is when this surface is not smooth, it's rough. Okay, good. And this is refraction. Refraction is the effect that produces the bending of light when it passes from one medium to another. So this is air. Air is surrounding this glass of water, okay, and light passes through air. And when light wants to pass through water, this is another different medium, light bends, okay, and this is called refraction. And we have time to watch another video about reflection and reflection. So pay attention to it now. Video.
Hi, I'm Becca Emmerich, the Educational Outreach Manager at Edmund Optics. Today, we are going to talk about absorption and reflection of light, and the reason we see certain things as certain colors. Absorption of light occurs when an object absorbs certain colors or wavelengths of light, not allowing the light to be either reflected or pass through the object.
Okay, so this is absorption, when an object or a substance absorbs some colors and reflects some of them. Okay.
Some objects, like this matte black photography paper, absorb all wavelengths of light.
Attention, objects that are black are objects that absorb all colors, so they can't reflect any color. So that's why we see them black.
And reflect no colors, such as red, orange, yellow, green, blue, or violet. Other objects, like this white table, do not absorb any visible wavelengths of light.
Attention, this is a white table. This table doesn't absorb any color, and it reflects all colors. And the sum up of all colors of light is white.
And reflect all of the colors to create white. In most cases, objects will absorb a portion of light, meaning that some wavelengths will be absorbed and others will not. Let's demonstrate absorption of light by using a flashlight and different colored filters. Remember, the light from a flashlight is white light and contains all colors of the spectrum.
So, in this flashlight, there are all colors of the spectrum of light, all of them, okay, are here in this light. Attention.
Let's start with this green filter. When we shine the flashlight through the filter, only green light passes through.
Attention, only green passes through. That's why this object is green. Okay? All colors but green pass through.
All of the other colors, including red, orange, yellow, blue, and violet, are absorbed, leaving only green to pass through. Now, let's take a look at this line. Colors such as red, orange, yellow, blue, and violet are all absorbed. Only the color green is reflected, which is why we see that color when we look at the line. Knowing that filters absorb light, let's think about what would happen if we shine white light through all the different colored filters. What do you think will happen? Can you take an educated guess? Remember, white light is made up of all the colors of the spectrum.
Attention, so you have here all colors, and this is the flashlight, okay? And all the colors in the light, in the flashlight, okay, are absorbed by all these objects. That's why we can't see any light passing through these different objects.
You guessed that no light will pass through because all of the visible wavelengths of light are being absorbed? You are right. Now we'll have some fun and demonstrate absorption of light using gummy bears and lasers. Here I have a few green gummy bears and a few red gummy bears. I also have a green laser and a red laser. When I point the...
Attention, this is a red laser. A red laser. So this is not light. This is only red. A laser that only red. Can you see red light passing through these objects here?
The red laser through the red gummy bears, the red light passes through. When I point the red laser...
And now, this is red laser, and these are green objects. And these green objects absorb this red laser. The only color that these things can't absorb is green, but this laser is red. So that's the reason why this red color can't pass through these objects.
Through the green gummy bears, the light does not pass through. This is because the red light is absorbed by the green gummy bear. Let's try the same experiment.
And you see here, so this red color is absorbed by this object. Okay, the only color that this object doesn't absorb is green, but this laser is just red.
And using the green laser. When I point the green laser through the green gummy bears, the green light passes through.
Now this is a green laser, so the green laser passes through. Why is it? Because these objects, this green color, repel, and they reflect green color, and that's why this laser, this green laser, passes through the object.
When I point the green laser through the red gummy bears, the light does not pass through. This is because the green light is absorbed by the red gummy bear. You can practice your knowledge of absorption of light wherever you go. Just remember that we see objects as the colors they are because colors from light that you can't see are absorbed, and colors you can see either pass through an object or they reflect off of an object. Check out edmondscientific.com for more fun videos and experiments.
Okay, thank you. Now go back again to the refraction of light. And you have here the refraction of light. You remember that this bending of light when it passes from a medium to another. So this is air and this is water. When light passes from air to water, light bends, and that's why we see objects that are inside water as broken or bent. So the bending of light as it passes from the transparent substance to another, like air to water, is called refraction. This is because different materials or mediums have different qualities, and lenses use refraction to help us see things. Telescopes help us to see things far away, and microscopes enable us to see very small things. Even glasses use refraction so that we can see everyday things more clearly. And we are going to finish this class with another interesting video. Pay attention to it. We're going to talk about refraction of light. Pay attention here.
Hay un orangután en mi cuarto y no sé qué puedo hacer. Ha cogido...
I want to swim, but I'm scared. I don't know how deep this pool is.
Hold on. Let's use this stick to check the depth of the pool. Can you see that its length is bigger than you?
Let's put it in the pool.
Okay. See? Half of the stick is outside. So you can go...
Can you see the stick? It is bent here. Can you see it? Okay. That's because light passes from air to water and it bends.
inside. It's not very deep.
But look, Ginny, the stick looks bent.
Yes, that is not bent. This looks bent due to refraction of light.
Refraction? Oh, you told me about reflection, but you never said anything about refraction. What is refraction?
You know, when light travels from one medium to another, it bends.
Like when it moves from air to water, one medium to another?
Yes, air is one type of medium and water is another type of medium.
Hey, even your hand looks bent.
Yes, and now you know that it seems bent due to refraction of light.
But why does light refract?
For that, you first need to enter the pool.
But why?
Go on, young man. To learn something, you need to do something.
Okay. This water is so cold. I want to come out.
Okay, but before you come out, try to run for some distance in the water.
I can't run faster. This water is stopping me.
Aha, darling.
Attention, attention. So the boy can't walk fastly through water. So the same occurs to light. So when light passes from a medium to another, it changes direction. So the same as is happening to us when we want to run across water. We are inside.
Now come out. Let's go home and learn more about refraction. So, Jimmy, you could not run fast in water, correct?
Yeah, I can run much faster otherwise.
Let's see. Why could you not run fast in water? You know, water is more dense than air. You have to run against air while on...
This is the wavelength length of light, and when it passes from air to water, it changes direction. Okay, it bends.
on ground, but your speed is less in water because the water is denser than air.
So, same thing happens to the light. When it enters water from air, its speed becomes less and its direction changes.
Let's do one more experiment to understand it more. Put this pencil in this glass of water.
Wow, this also looks bent.
But we know for the fact that pencil is actually not bent. It is refraction. Let's look at it in the details. See, the light reaching the eye is coming from a different direction.
Yeah, because light changes its direction when it travels from air to water.
Yes, it enters from one medium to another, so it changes direction due to difference in density of the two mediums. This is refraction.
So guys, now you understand refraction. Now, time for some homework. It is easy. Okay. Your homework is to take a pencil and put it in a glass of water. And remember that the bending of the pencil is due to refraction. And your second homework, my friends, please press the like button below. Thank you. Bye.
Okay, now this is the end of our exercises. Remember, today you got to try to do some exercises in your natural notes. Okay, 19 and 20. This is for today. Okay, so now going to see us in just a moment. Thank you.